Hi everybody, welcome to the NMC Drone Shop. So today we're going to go through drone components. So we'll take a look at some of the parts that make up a drone. And my trusty drone here, this is the DJI Mavic Pro. So most drones, whether it's a DJI system or a different one, are made up of the same components or the same basic components. Even if it's a completely different brand or something that you build yourself, some of the main components are still the same. So very important to understand those components because it will make you a better pilot, a better operator, a safer operator, and you'll be able to do maintenance a lot better on your drone and be able to troubleshoot things and whatnot. So after you watch the video, you should be able to understand the following components. So we'll be taking a look at the flight controller with inertial measurement units, GPS, the magnetometer, brushless electric motors, static air pressure sensors, ultrasonic sensors, communication link, which is basically your handheld transmitter radio, and the batteries. So let's just jump right in and we will talk about, let's start off with the brain of the drone. So the brain of the drone is called a flight controller. And inside here, there is basically a circuit board that has what's called IMUs, or inertial measurement units. Big fancy name. So if we look at a flight controller like this one happens to be a flight controller that is in a box, like that. So in there are some small chips that sense attitude. So what I mean is, I'll put this back down. So this little box, and again, these are pretty much like in all drones. All drones have some type of flight controller and autopilot, whatnot. So there are small chips in here that can sense attitude. So if it tilts one way or another, if you can imagine this being in a drone, so if it's tilting one way or another, it senses that and can send commands to the motors or other parts of the drone to correct its attitude or whatnot. So even if you've never flown a drone, you've actually had experience with IMUs, inertial measurement units. They are in everything nowadays. If you've ever played Nintendo Wii with the controllers, those hand controllers, they sense motion, they have IMUs in it. Your cell phone has IMUs in it. Because when you turn your cell phone one direction or another, it flips the screen, or maybe you even have a carpenter's level in your iPhone or phone that helps sense, where level is or the horizon or whatnot. It is IMUs that does that work for you. So they're in basically everything. Actually, if I was a smarter person, I could actually take a cell phone, stick it on top of a drone, if this was my cell phone, stick it on top of a drone, and actually use the IMUs in a cell phone to actually fly a drone. So back to our Mavic. So those IMUs that are in here gives the drone its stability. So if it's tilted one way or another, it senses that and can send the commands to the motors to make it go upright. This actually is what allows us to fly kind of hands-off with a drone versus something like a remote control helicopter, like that up there. Those don't have any stability whatsoever. So if you let go of the controls, it'll just roll over and crash. Where these, if you let go of the controls, they sit in one spot. And it's thankful to those IMUs that give it that stability. So I hope that makes sense. If we look at some homemade drones, this is a homemade drone. This is the flight controller on this drone. So this is something that I'm building, just putting it together. So the flight controller is this orange cube, and that cube in there has those inertial measurement units, those IMUs. Again, it's kind of the brain of the drone. So the next thing that we want to talk about is GPS. Now, I'm not going to get into a lot of detail about how GPS works. I think we're probably all pretty well versed on GPS. We have satellites in space, and it's being received by a receiver, whether it's in a drone or your telephone, and it triangulates its position very accurately, probably accurate within about 10 feet. At least it is on drones. So because of that, or because GPS systems have gotten so good, small, light, cheap, all that kind of good stuff, they found their way on drones. And GPS is the primary means of navigating for a drone. Now, looking at our homemade drone, this is the GPS on this one. So the GPS receiver is in here. And what GPS will do for you, other than navigating, like if you want to go to a certain location, yes, the GPS system will take you there. But the other thing that it does is it allows us to fly hands off a bit more. So we were talking about those IMUs and how well they work in your drone to help stabilize it, keep the wings level, if you will. But now the GPS will help hold position. So in other words, when you're flying around and you let go of the sticks, the drone just stays in one spot. So you combine that ability, so the ability for the drone to just sit there all by itself, along with the stability of those IMUs, and now we have something that actually flies really easy. It allows us to be able to take our hands off the sticks. The thing just sits there, and we can think about what maneuver we want to do next or where we want to go with the drone or whatnot. The other thing that the GPS allows us to do is have the return to home functions. So most drones will have the ability to, you push a button and the drone will just come home on its own. Or as a safety feature, if the battery's going dead or we lose our communication link to our drone, the drone will just return home on its own. So that's all done with GPS. So if you lose your GPS, you're going to lose those abilities. So the drone won't fall out of the sky. It'll still actually hold level. It'll be stable. But without GPS, it's going to start wandering with the wind a little bit. You'll lose your ability to just push a button and have it fly home. So at that point, you would have to just fly home on your own. So it's not the end of the world if you lost your GPS when you're flying, but it sure is nice to have it. So the next thing I want to talk about, and it goes along with the GPS quite often, or they're almost co-located. It's called a magnetometer. It's like, wow, what is that? Magnetometer. A magnetometer is a compass. It's an electronic compass. So if we look at our homemade drone, this one, there's a magnetometer in this puck up here. There's actually also one in here. We've got a couple of them. So just like what we were saying, it's a compass. A magnetometer is just a fancy name for compass. So very important that a drone understands its heading, because that's what we use a compass for typically, right? It's like, which direction are we heading? We're heading east, we're heading south. A drone needs to know that. It needs to know which way it's headed. I'll use my smaller drone. A little easier to understand with this little one. So this one has a magnetometer in it as well, a compass. So the one thing about a drone, a multi-rotor drone, is, well, think of it this way. Which direction can it fly? It can go any direction. So in other words, forward and back, side to side, it can rotate, it can do all kinds of stuff. It's not like an airplane. An airplane is always driving itself forward. Well, these multi-rotors don't work that way. They can be flying, like we were just saying, it can be flying in all kinds of different directions and attitudes and all that kind of stuff. So it's very important for that flight controller, the IMUs, the brains of the system, it's very important that it understands the nose of the drone. So if you tell it to fly that way, it knows how to do that, turn and go that way. Or maybe you put the sticks in sideways and it's going to fly that direction, but now it's going to fly this way. So yeah, very important. A magnetometer is very critical to a multi-rotor. So again, it's there to help provide heading information to the flight controller. Very important that it understands that orientation. If you lose your magnetometer, in other words, if you have some problem with it, or if you're flying close to some certain objects, you might actually experience some problems. And it can actually be a very big deal. So if you lose your magnetometer, you lose your compass, your drone could actually kind of start spinning off into nowhere. Pretty hard to deal with a situation like that, and ultimately, if it's bad enough, it'll lead to a crash. So actually losing a magnetometer is a big deal. Fortunately, they've gotten very robust and they work quite well. Some areas where you might experience trouble is typically it's on takeoff, and it's where you place your drone. So if you think of it this way, if you're trying to take off and you're next to a big giant metal object, steel, it could send different compass readings to your drone because the steel object is creating a magnetic interference and it can't sense where magnetic north is, right? An issue with this is, believe it or not, trying to take off on concrete. So if you put your drone down on concrete, sometimes on your screen, it'll actually say compass warning. It's kind of weird. And all you have to do is pick it up and put it on some asphalt or the grass, and it's fine. Well, the reason why is there's rebar in concrete. There's steel in it. If you are trying to, say, fly out on an oil rig out in the middle of the ocean, there's nothing but a big chunk of carbon steel out there. Very difficult to operate in those situations. You have to go through a lot of hoops, so to speak, to actually get your compass to function correctly because of all the magnetic interference. Another place where you might experience some problems is when you are flying close to like power lines or actually just any real big steel object. Most of the time, if you're flying, your system will actually start to warn you that there's an issue with the compass. It'll say something about like weak compass or compass interference. It'll usually tell you that before it gets really bad. And at that point, you can just get away from where you're at. So hopefully it's not a permanent thing, and then you can just fly home or climb and get away from it. All those good things to keep your drone in the sky. So the next thing that we're going to be taking a look at are the motors. Pretty important component, right? That's what makes the whole drone fly. So they are just electric motors, but something a bit more. They're called a brushless motor. Now you might have heard this term before if you're buying a newer drill or heck, even some electric powered vacuum cleaners. Are advertising now that they have digital motors or brushless motors. And this is a good thing. So if you actually do see that term, brushless motor or digital motor, it's actually a good thing because a brushless motor is a lot more efficient, generates a lot less heat, doesn't generate sparks or anything like that, and overall just function so much better. They last a long time and they don't get very hot when they're running. So how are they different? So let's take a look at just how an electric motor works in the first place. So an electric motor by itself, they're actually pretty simple. Now this is a cutaway of a normal electric motor. And really all an electric motor is a spinning magnet. So electricity comes through here and it goes through these brushes. And then it goes through these windings and it creates an electromagnetic field. And it causes the motor to rotate. I'm not going to get hugely into that. I mostly just want to focus on why a brushless motor is so much better. So in a standard electric motor, again, we have these brushes. So this part is actually spinning. This is called a commutator. So this part is actually rotating with this whole stator. So there's friction right here. So electricity is coming through here, through this wire, going through these brushes and making contact with this commutator, they call it, and it goes through these windings and it creates magnetism and it causes the motor to spin, and then it comes back out this side. Well, basically, mechanically, as this thing rotates, it's shutting off and turning on different segments of this winding. So we're turning on and off the magnetic field in the motor. We're turning it on and off mechanically through these brushes. And right in here, because this part is physically riding on this spinning part of the electric motor, we get a lot of friction, a lot of heat built up. We actually even get some sparks and arcing and that kind of thing inside these motors. And we're losing a lot of efficiency in the process. So what they've done with brushless motors is they actually turn on and off the magnets electronically. So they instead of using a mechanical means to turn on and off the electrical windings that create the magnetism, they actually do it electronically through a circuit board. So basically a brushless motor has to have a little bit of a brain, if you will. And that brain is called an electronic speed control, which we'll talk about next. But what we have is an electrical controller that's turning on and off the magnets rather than something mechanical and physical. So since we're able to get rid of these brushes, and now we're turning on and off these windings electronically without any physical connection, we're able to have a motor that creates a lot more energy. It's going to run a lot cooler, and we're not going to have all the sparking and arcing and all that kind of good stuff. So kind of in a nutshell, just real basically, that's how they work, and that's why they're so much better and efficient than just a old-fashioned normal electric motor. So the next thing I want to talk about are electronic speed controllers. So we just got done talking about how great brushless motors are and how efficient and all that kind of good stuff. So this goes along with the brushless motors. And here's an electronic speed controller right here. So in here are a bunch of these. Well, 4 of them, 1 for each motor. Now, they might look a little different. If you pop the lid on that one, they're probably more integrated into the complete circuit board. But this is what they are individually. And yeah, it doesn't really look like a whole lot. This is a 45 amp brushless speed controller, also called an ESC, just ESC for short. So all it's really doing is taking the battery power and it's taking the signal from your inputs or the inputs of the flight controller, say to keep the drone level, and it's just instructing the motor how fast it should turn. Should it speed up, slow down, stay where it's at? So pretty simple idea, but just so you know what they are and that they're really kind of the other part of a brushless motor. It is the brain of the brushless motor. One thing I want to talk about, and you actually can't see it, it's called a static air pressure sensor. Like, wow, what does that mean? So how does this thing hold altitude? So you go up, and it sits really nice at a certain altitude. How does it do that? It's actually not using the GPS. GPS is not very good when it comes to determining altitude. So it's actually pretty accurate horizontally, but within 10 feet, but it's probably 2 to 3 times worse at detecting your altitude. So they're not using GPS to help hold altitude. So what they use actually is air pressure. So when you think about the term static air pressure, it's just the air around you, how much pressure is around you. So what happens when we go up in altitude to the air pressure? It becomes less, right? So even altimeters on an airplane, that's what they're basically measuring. They're measuring that change in air pressure. believe it or not, the little sensors on here can actually tell the difference between right here and right here. So as you climb, the air pressure is changing. Once it reaches the altitude that you want, you let go of the stick so you don't want it to climb anymore, it locks that in. So it's actually using that static air pressure sensor to maintain its altitude. So pretty crazy that these things can actually measure air pressure that precisely. So pretty simple, not a whole lot to explain there, other than that, yeah, it's called a static air pressure sensor, and it's literally just measuring the pressure of the air, the differences as you go up in altitude to maintain that altitude. So the next thing I want to talk about is ultrasonic sensors. And if you look at pretty much any drone on the bottom, let's see if we can zoom in here. So these little guys on the bottom, these two little dots, those are the ultrasonic sensors. And what that is it uses sound waves to ping the ground. So when it's sitting like this, so there'll be a little sound wave that comes out, hits the ground and comes back, and it measures the distance. Now, earlier we were talking about the static port or the static pressure sensor being able to measure altitude for us and hold altitude based on air pressure. And they work great, but the problem is it still isn't good enough to know exactly where the ground is at all times. Or if you take off on one spot and you go to land in a different spot, the altitudes might be different. So what was altitude 0, where you took off from, might be a little bit different where you're landing. So they put these ultrasonic sensors because they're very precise at measuring exactly where the ground is. So when you're coming into land, it'll actually be pinging the ground, and it knows exactly within inches where the ground is, so it can adjust its descent rate and do its automatic landing and all that kind of good stuff. They work great. They're very accurate. They provide a lot better landing security, if you will, so it doesn't go crashing into the ground too fast or anything. They do only work probably about 10 feet or so off the ground. So in other words, after you climb about 10 feet away from the ground, they don't work anymore. So when you're up there flying around at 300 feet, they're not working. It's still going to be relying on the pressure sensor, the static air pressure sensor, for its altitude. And those ultrasonic sensors are really only used for takeoff and landing, or if you accidentally start flying a little bit too close to the ground, it could also pick up the ground. So pretty straightforward. Sometimes different drones might use what they call LiDAR for that. It's basically the laser equivalent. So instead of sonar, instead of sound waves, they're actually starting to use laser beams to ping the ground, if you will, and it reflects back and it gives a very accurate distance reading to where the ground is, so it can be a lot more accurate with its takeoffs and landings. Pretty straightforward little device. Yeah. So one other thing that I want to chat about just real quick, and this is primarily a DJI thing. So this isn't going to be on every drone, but mostly on these DJI consumer drones. So a couple things. These little things up here that kind of look like nostrils next to the teeth. Those are little cameras. And on most DJI drones now, they have these little cameras all around the drone. And what those are anti-collision cameras. So if you're flying close to something, the drone can basically see that there's a wall there and it won't fly into it. Now, works actually very well. You have to have good lighting, so they don't really work the greatest in like if it's dark out, because they're cameras. But you don't want to rely on them 100% to avoid obstacles for you. They work great on larger obstacles like a building, a wall, a tree, but not necessarily like the little branches. It might miss wires and small branches, especially if there's no leaves on them or whatnot. But they actually work quite well otherwise. And these are just little cameras that are all around. And basically they're just being able to detect its surroundings through the use of these little cameras. The other thing on the bottom, they also have downward facing cameras right here. And these have a little bit of a different purpose. So in a GPS denied environment, so we talked about GPS, and GPS helps hold its position, helps you navigate from point A to point B, but it also holds position. Well, what if you don't have GPS? So what if you're inside or you're flying under a bridge and you just don't have that good a GPS? Well, without GPS, your drone's going to wander. It's going to blow with the wind. It'll still be stable, but it's going to blow with the wind, and you have to be the GPS at that point. You are responsible for maintaining its position, and you're responsible for the navigation and all that kind of good stuff. Well, what DJI did is they put these tiny little cameras. So these are the ultrasonic sensors, but these little guys up here and this one down here is a little tiny camera. And what that does, and you still have to be relatively close to the ground, it's almost like the ultrasonic sensors. So anything above 10, 15 feet, they probably don't work the greatest. But what that does is actually help stabilize the drone, because those little downward facing cameras can actually sense movement. So when it sees the ground underneath itself moving, it goes, nope, I don't want to move. I'm going to hold position. So DJI aircraft, because of those optical sensors, those cameras, that it actually holds its position quite well without GPS, assuming that you're not 300 feet in the air. So you can actually be out flying. Let's, for a scenario, you're out flying around, you have good GPS, and now you fly into a garage, and all of a sudden the GPS goes away. Well, the system by itself will just switch and actually start using those downward facing cameras and go into what's called opti mode. It's optical mode, and it'll use the ground then to help maintain its position. You can't navigate with it, but it'll help stabilize the drone so it doesn't wander all over the place. So pretty cool little invention that they added to that really helps fly these aircraft. So the next thing I want to talk to you guys about is your radio. Now, this radio is from a DJI Phantom series of aircraft, pretty typical. iPad sits up here, here's your antennas. If you have a Mavic or some other drone, it'll look a little bit different, but the functions are basically the same. Not going to get into a lot of the different, what the sticks do and all that type of stuff, but I did want to talk to you more about the communication link itself and these antennas. So most normal drones, or just your consumer drones, they operate on a 2.4 gigahertz. And the reason why I bring that up is there's a lot of other things out there that operate on 2.4 gigahertz. And like Wi-Fi being one of them, Bluetooth. So there's a lot of other consumer products out there that actually operate on 2.4 gigahertz. It's one of those like open frequencies. And you might notice if you're in areas with a lot of radio noise, a lot of Wi-Fi, that kind of stuff, that you could experience some problems with that. So it's just something to think about. The other frequency that drones typically operate on is 5.8 gigahertz. So oftentimes they're using 2.4 to control the drone, but then they use 5.8 gigahertz for the video feed. So more of just an awareness than anything, the frequencies that they operate on. Most modern drones, it's amazing how good the radio link is to the drones and actually how far you can actually fly your drones. They'll actually fly further than you were legally allowed to. So remember, we have to keep them within line of sight. That's what the FAA says. So you have to be able to see it. Most drones that are this size, even about a third of a mile, definitely a half a mile, they're really hard to see. If you take your eyes off them for a second, you can't find them again. But the radio transmission they'll carry them out there 2, 3, 4 miles. So the radio transmission is actually better than your ability to see the aircraft. So pretty crazy in that regards. Some things that'll affect your range if you are, again, around a lot of other radio noise. So if you're in a busy city, there's a lot of cell phone towers, that kind of stuff, you might notice that your range on your drone isn't as good as if you're kind of like out in the middle of nowhere. If you are trying to transmit through power lines, or anything metal that's in between you and the drone, it's going to cause some problems. So like, let's say there's a big metal fence between you. Even if you can see through it, the radio signal doesn't go through it very well. And again, through like power lines. So if you're flying on the other side of the power lines, so the power lines are in between you and the drone, you might notice your drone going lost link. Now, losing link to your drone, so losing connection to it, it's not a huge deal. I shouldn't say that it's okay and that you shouldn't care about it, but it shouldn't crash the drone. So most modern drones have some type of safety feature that if you lose connection to your drone, it's not going to just fall out of the sky. So what'll happen is the drone will lose connection. Typically it's going to tell you that on your iPad or whatever you're using. The drone will climb to a preset safe altitude that you set prior to takeoff, and then it'll come home at that altitude and land. So really, I'm not saying to do this, but really you could turn your transmitter off and walk away and come back, and your drone should actually be sitting there where it took off from. Don't do that though. But that's how good the systems have gotten. So yeah, a little bit about communication links. So the next thing I want to talk about are the batteries. So lithium polymer batteries. This is what's powering your drone, and actually, quite honestly, it's almost powering everything now. Your cell phones, your laptops, all that kind of stuff typically have some type of lithium ion or lithium polymer battery. So drones are using lithium polymer batteries, and this is more of like a hobby grade one. It's just you put it in an RC airplane or your homemade drone or whatever. Most of the time, boop, your batteries are going to be something like this. Again, this is off of a Mavic. So lithium polymer batteries work great. They have a lot of voltage. They store a lot of energy for their weight, and it's really allowed a lot of things to become electric powered, even cars. That's coming down the road, Tesla cars, all that kind of good stuff. So our drones typically almost always use lithium polymer batteries. Pretty straightforward, not a big deal, but there are a few things. The one thing, it's more of safety concerns than anything. So, like I mentioned, lithium polymer batteries work great. They do have some downsides though, and one is if they're not treated well, and I'm not trying to scare anybody with this, but they can actually start on fire. Now, if you have a consumer drone like this, always just use the charger that it came with, and there's a lot of intelligence built in. It monitors the battery as it's charging it, all that kind of good stuff. At that point, it's really almost kind of like your cell phone. You just plug it in and you leave it. Now, if something malfunctioned in your charging system or whatever, and the battery continued to charge and it didn't shut itself off, the potential for a fire actually does get pretty great. And unfortunately, when these things burn, they burn pretty hot. If you want to experiment a little bit, or if you want to see a little bit more about that, just search that on YouTube, lithium polymer fires, and you'll see a lot of stuff. Again, it's not to scare you, but it's more of just an understanding of what these things are. Now, again, if you're using a drone, a professionally built drone like this one, typically not an issue unless you're really doing something stupid. But if you're using it the way you're supposed to, it's not going to be a problem. The hobby batteries are probably a little bit more likely, I would say, to start on fire. Not so much because they're bad or less quality or something, but when you're setting up your charger, there's more options as to like the voltage settings and all that kind of stuff. So kind of my point is there's a little bit more likelihood of human error when you're setting up your charger to charge these things. So just be very careful. What I always recommend people do is when you're charging them, be around. I mean, you don't have to sit there and stare at your battery, but don't throw it on a charger and leave for the day while it's charging. I know we have a tendency to do that with our other devices like our laptop computers and all those types of things. But with these things, even if you're charging a DJI system or whatnot, just be around. They charge in about an hour anyway, so it's not like you really have to leave them for a long period of time. So if I'm leaving or going to bed or whatever and I'm charging my batteries, I'll typically unplug them. It's also not a bad idea to charge them in a relatively safe place. So in other words, don't lay them on the carpet. It kind of holds heat anyway. Put them on a countertop, a floor or something like that. So heaven forbid something happens, it's not going to, catch the curtains on fire and all that kind of stuff. But again, I'm not trying to freak anybody out, but it is just one of those things to be aware of, that there is a slight fire potential with lithium polymer batteries. But quite frankly, they've gotten a lot better at being safe and all that kind of good stuff. So use them the way you're supposed to. So a few other things. Don't use your batteries if they've been damaged. So like if you crashed your drone and there's a crack in it or they're squished up or something like that, you should actually get rid of them at that point. And I guess the correct answer would be, how do you get rid of your battery? So the correct answer would be to follow the manufacturer's guidance on disposing of your battery. I think there are some battery recycling centers, that kind of stuff. But as far as like the FAA questions and all that kind of, those types of things, the correct answer is follow the manufacturer's guidelines on disposing of your batteries. The other thing that can happen with these things, they start to get poofy. This one's actually really good still, but if they've been used and abused a little too much, if they've been run hot, they'll actually start to poof up. And you'll actually see it, they get really billowy. That's another reason to not use them anymore. These, because they're in a hard plastic case, they'll actually start to split the case. And you might not actually be able to get it in your drone anymore. And that's actually a pretty good indication that it's like, yeah, maybe I shouldn't be using this thing, and just replace it. So don't use batteries that have been damaged or ones that have been poofed up or anything like that. Some other things with battery temperatures, like temperature outside. LiPo batteries don't like heat. So avoid storing them in hot locations. If it's summertime, don't leave them in your garage when it's 100 degrees out. Keep them nice and cool. If you accidentally freeze them, like you left them in your car overnight and it's wintertime, it actually won't hurt them. I wouldn't recommend just doing that, but if that happens to you, bring them inside, let them warm up to room temperature before you use them or charge them or anything like that. So the cold is actually okay as far as storage is concerned. They just don't like the heat. They don't like the heat when they're running either. So most systems will have a battery temperature monitor. So when you're flying, it'll actually tell you the temperature of the battery. And if the battery starts to overheat, it'll warn you of that, and you should land right away, because you're, at the very least, you might damage your batteries. The other thing, you could have an in-flight fire or just a power failure of some kind. That would be the worst scenario. So just land right away if your batteries are getting hot. One more thing with these is it's really strange, but if you discharge them all the way, they won't work anymore. So what I mean is, and it's not very common with consumer grade stuff that you're using appropriately. And I'm not talking about flying your drone to the point where it says that it's empty. I'm talking about actually depleting it. So if you have a battery like this, and let's say you put a light bulb on it and you just let the thing completely go dead, it actually won't take a charge anymore. It's really weird. It's just something strange with lithium polymer batteries. But if they are actually discharged completely, they won't take a charge anymore. And you actually have to throw them away. If you try to charge them, usually the charger will actually say, no, I'm not going to do it. But if you try to force charge them, they actually might start on fire. They don't want to charge anymore after that. So it's just one of those things. Again, if you have a consumer drone and you're using batteries like this, the drone itself protects the battery from getting discharged all the way. So you don't have to really worry about it, but it's just something to note. The other thing is storage as far as voltage is concerned. You can see on here, if I push this battery, it's just got 2 bars, 2 out of 4. So when you're storing lithium polymer batteries, they actually recommend keeping them at about half charge. So not completely full, but about half charge. It's just called storage charge. Now, the really cool thing, if you do have a DJI system, those folks are so smart, these will actually self-discharge by themselves. So if you charge this battery, in 10 days, it'll actually start to self-discharge and go into storage mode. So it's kind of a good and bad thing, because on the 11th day, you go to fly your drone, and it's like, okay, I'm ready to go. All your batteries are half dead. But it's nice because it protects the battery and it keeps it lasting longer. LiPo batteries are good for about 200 cycles, it seems. So after you've used it about 200 times, it'll probably need to be replaced. You'll start to notice decreased flight performance, and it just doesn't seem to fly as long. Oh, another good thing, if you have multiple batteries, it's actually good to label them like 1, 2, 3, 4, because it helps you keep track of your batteries. So when you're out there flying, you'll notice that, hey, old number 3 just doesn't seem to be performing very well anymore. Now you can identify it easier and replace it. So it just helps you keep track of your batteries and how well they're performing. It also helps, I've seen a lot of times people just write the date, like when they put it in service, so to speak, because along with the 200 cycles, it also seems like after a few years, 2, 3 years, they start to get a little bit, they just start to not work quite as well. So having the date on there is helpful. Again, just helps you identify that maybe you have a poor performing battery. So just a few things about your batteries.